All right, welcome everybody. So we're going to go nice and slowly today because every single problem that we have is a word problem. When doing word problems, just to give you a couple of tips, you're going to want to read the problem through a few times. Make sure that you're really comfortable with the scenario. You deeply understand it. A lot of times I'll find that I was thinking the wrong way or solving the wrong way because I really truly didn't understand the problem at hand. Another thing you want to keep in mind is what section are you on? If you're on the section where you're studying inequalities, then you're probably going to have something set up with like a less than or or equal to, greater than or equal to. Okay. In this case, we just learned quadratic equations. So probably all of the word problems we're going to set up today will involve some sort of quadratic equation. If it doesn't, then I might think, okay, maybe I didn't set this up correctly. Now, that might not always work. Like on a test, you have multiple sections, so you really have to think. But when you're doing your homework, usually you know what the topic of the day is, and so that can kind of guide you a little bit. All right, so let's go ahead and start here with this first one. So it says the width of a rectangle is 2 meters less than 1/4 of the length x. The area is 96. Okay, so what we're looking at here is a rectangle. I always like to get a drawing in there. So let me just put a random rectangle in there. Okay. All right. So for this one, and just to like not be confused, you guys, I'm going to put it on its side really quickly. That would be helpful if I drew it this way. Okay. All right. So the width, my OCD is kicking in, you guys. This is not straight. I'm going to have to let it go. Okay. All right. So it says the width is 2 meters less than 1/4 of the length x. So if you read carefully, they're saying straight up, the length is x. You can read that sentence a few times, but you can see with this statement right here, 1/4 of the length x. So I'm going to label the longer one, the length x. Now I have to worry about what the width is, right? The width of a rectangle is 2 meters less than 1/4 the length. If you were to do that word for word, right? You just took that, and as they're saying in English, you say it in math. A lot of students might interpret it this way: 2 meters less than, they'd put minus, and then 1/4 of the length x. Okay. And I can see why a student would do this, but this is actually wrong. Turns out that whenever you have the words less than, not is less than, just less than like this, that means that you have to take what's in front of it and what's behind it, and you're going to have to flip-flop the order anytime you see less than. I'm going to type that out. Okay, don't forget to flip the order when you see quote less than. Okay. Now, let's talk about that, because it's one thing to tell you and you memorize it. If I tell you and you memorize it, you're going to forget it, right? So we want to make sure that you hold on to it for a long time. So what I want you to consider, I'll probably delete this slide in a second, but I want you to answer the question for me, and don't think too hard, okay? What number is 2 less than 5? Okay. And just don't even think too hard. What number is 2 less than 5? Hopefully you came up with the number 3, right? Okay, if you're on a number line, here's 2, 3, 4, and 5, right? Okay. If I'm at 5, 2 less than it would be right here at 3, right? Okay. Now notice, we didn't do this. We didn't do 2 minus 5. That would be what this would be if you went in order, right? 2 less than 5. Okay, and I just told you a second ago, that is incorrect, right? 2 minus 5 is -3, you guys. So there's no way that that's correct. Okay, so the correct way to do it would be what we just said, which is just flip-flop the order on it, right? So instead of the 2 being first, right? These two, whenever we see the words less than, are going to flip-flop positions. So it's actually going to be 5 minus 2. Okay. So don't forget to flip-flop whenever you see less than. And you know what I'm going to write below this? See next slide, okay? Okay. All right, so back to our problem at hand then. So what we're saying is that when we write out 2 less than 1/4 the length x, it's actually going to be this way: 1/4 the length x, take away 2. That's what's going to be our length and our width in this problem, okay? All right, so we're just going to go ahead and bring that in here, and we're going to place it right here where the width is. That's how wide this rectangle is. Okay. All right. So and by the way, I flipped this rectangle and stuff, but it doesn't matter, you guys, what you call the length and the width. You could have actually called this shorter one the length and this longer one the width. I mean, it doesn't matter. It's all arbitrary. I mean, you could knock this rectangle on its side and draw them this way, right? It'd still be the same rectangle. Okay. All right. So let's take this last sentence now and digest it. This last sentence says the area is 96, right? Okay. So if the area is 96, let's start off by writing the area of a rectangle formula, right? So the area of a rectangle is either base times height, or in this case, length times width, right? So what we're going to do is we're going to substitute in everything that we know. We know the area is 96 according to the word problem. So let's put that in there. We know the length is x, just look over at our picture. And we know that the width is 1/4 x, take away 2. Okay. All right. So now all we need to do is solve this, okay? Alrighty, so we're going to go ahead and distribute that x into the parentheses. So that's going to get us 96 equals 1/4 or 1/4 x times x will get us x squared. And then we have x times 2, so 2x. Now, I don't particularly like dealing with fractions, so I clear the fractions by multiplying by the LCD to everything, because it just makes it a lot easier to have whole numbers or integers. All right, so 4 times 96. Let's see here. That'd be a 4, carry the 2. I think it's 384. Okay, hopefully that's right. Let me just double check it. 4, carry the 2, yeah. All right, and then here the 4s are going to cancel with each other, just leaving us 1x squared, or x squared. And then 4 times 2 is going to get us a negative 8x. Now, we learned last time that when you're solving a quadratic that has both an x squared and an x, you want everybody on one side. You want it set equal to 0, right? So we're going to have to take this 384 and move them over to the other side so we get that equals 0. And now this quadratic is in what we call standard form. Now, if you're a person who just loves the quadratic formula, then go for it as far as the quadratic formula is concerned. I like factoring better, so I'm going to take a little bit of time to see if I can find the factors of negative 300. I should do this in red. Find the factors of negative 384 that add up to negative 8. Okay, so I'm just going to tinker around off to the side. So 384, let's see here. I know 2 goes in, right? I should probably grab a calculator, guys. Give me a second. Boy. So there is a rule that says if the last 2 digits are divisible by 4, then the whole number is divisible by 4. So let's see what 384 divided by 4 is. I got 96. So 4 times 96. I'm not going to do this too, you guys, because it's clearly too small. So we're way too small because these don't have a difference of 8, right? So I'm going to keep trying. I'm going to divide it by 12. Let's see, 384 divided by 12. Okay, I'm getting closer. 12 times 32. Okay, those don't have a difference of 8, so I got to go even higher. So let's see here. 384 divided by, let's try 16. I got 16 times 24. Will that do it? That will do it, you guys. I think I just need a negative here. Okay, so negative 24 and positive 16. When you add them up, you get negative 8. And when you multiply them, you get 384. Okay. So as long as you have a calculator, that's not too bad. Just divide by 2, divide by 3, divide by 4, just kind of tinker around until you find it. All right. Otherwise, you can use the quadratic formula. And there's other methods too, but maybe I can do a video on methods for that. All right, so that means we're going to put negative 24 and positive 16 into our parentheses. Okay, so we're going to set each piece equal to 0 using that zero product property that we learned last time. So if we set x minus 24 equal to 0, when you add the 24 over to the other side, you get x equals 24. And when you set x plus 16 equal to 0, and you move it over to the other side, you're going to get a negative 16. Now, in these word problems, a lot of times one of the answers will be bogus. It won't make any sense because now we're not just in this abstract algebra land, we're in the real world, okay? So I'm looking at the negative 16. Now remember what x stands for. If you look in our picture, x is how tall, it's the length of the rectangle. Well, the length of a rectangle can't be negative. Nobody gets out a tape measure, measures the rectangular table and is like, yeah, it's negative 16 feet, right? So anytime that you have a negative length, you're going to cross it off. So let's just put no negative lengths or distances. No negative lengths. Okay. All right. So that means that the answer has to be 24, or at least part of the answer. So another thing is this one doesn't really, it's bad directions. It doesn't tell you what to solve for. So we're just going to solve for everything because I remember from Connect Math that it usually wants all of it. So let's go back here. We now know that x equals 24, right? Okay. And that is our length. So let me put that above it, length. But it might ask you to find the width too, right? So if you want to find the width too, you're going to take that 24 that you just found and you're going to substitute it in where x is. So we have 1/4 times 24 minus 2. Okay. All right. So we'll put a 1 underneath the 24. So it's going to be 24 over 4. And that's just 6 take away 2. So it looks like it's going to be 3, you guys. So the width is going to be 3. Okay. Let me write it like this so it's nice and neat. So, oops, sorry, you guys. Okay. 1/4. Oh, I'm stuck on, I don't know why it's stuck on text there. There we go. All right, 1/4 x take away 2 is equal to 3. Okay, so really these are our two answers, right? 24 and 3. And you know what? It's in what? Meters, you guys. So if you want to be really good, you tack an M on there for meters, right? Okay. Wow. Okay, so it's not very good to grab with my pen. Oh, interesting. Sorry, I'm used to this on the whiteboard where I can just grab that with this pointer. And now I have to select it. Yep, okay. I'm gonna leave it. All right, so hopefully, you feel pretty good about that problem. Let's kind of recap some of the big things. When we see the less than, flip-flopping the order was a big moment because normally, you just go word by word and write it down, but not in the case of less than. We did a clearing of fractions here, which was kind of smooth. So that way we didn't have to work with fractions. And it gave us the easier case of factoring. It gave us no leading coefficient. So really that was the best way to go about it. We said here, if you're uncomfortable with trying to find these factors, then you can always do the quadratic formula. If you end up with a negative in the end, plug it back into your problem and see if it makes sense. If it does make sense, keep it. If it doesn't, cross it off. All right, let's try another. The three sides of a right triangle are represented by 3 consecutive integers. What are the integers? Now, if it's a test in my class and you just know the answer,
because you tinkered around, that's fine. You used logic to get it still. I'm cool with it. Or maybe you even remember the 3, 4, 5 right triangle, the Pythagorean triple from geometry class or something. So you just wrote down, 3, 4, 5. I'd be fine with that. Okay. So it is a 3, 4, 5 triangle, but let's go in and show that indeed it is 3, 4, 5 for those of us that didn't know that. Okay. So the three sides of a right triangle are represented by 3 consecutive integers. What are the integers? So we're going to have the first number, the second number, and the third number. Okay. And I'm going to let the first one be x. So the next one has to be x plus 1. And the next one would have to be x plus 2. Let's kind of talk about that, okay? Integers are just positive and negative whole numbers. So that means we're not allowing fractions, okay? We're not allowing decimals. So an example of consecutive integers might be like 5, 6, 7, okay? 10, 11, 12, who knows, okay? But those would be 3 consecutive integers. If you decide to let the first one be x, well, the distance from 10 to the next one, it's 1 away. So that means this one would be x plus 1. If you're looking at 12, 12 is actually 2 away. So it would be x plus 2. And you can check to see if you're right. If you were to put in x is 10, right? X is 10. If you were to put in 10 into all of these, right? Let me put commas. 10 plus 1, 10 plus 2. Notice you get 10, 11, and 12. Okay. So that's if they're consecutive integers. It could be where they say something like, are there consecutive evens or they're consecutive odds? So let's look at the case of consecutive odds, and it turns out evens the same. So if I have consecutive odds, like let's say I have 3, 5, and 7, those would be consecutive odds. Well, if I let the first one be x, then the next one actually has to be x plus 2, and the next one has to be x plus 4. And that is because 5 is 2 spaces away from 3, and 7 is 4 spaces away from 3. So if x is 3, the first number is 3, you would get 3, 3 plus 2, and 3 plus 4. So there's your 3, 5, 7. Okay. And it's the same for consecutive evens because they also are 2 spaces away from each other on the number line. So both evens and odds are going to be x, x plus 2, x plus 4, x plus 6, x plus 8, depending on how many we need. All right, so we have consecutive integers, so they're only 1 away from each other. So that's why we have x, x plus 1, x plus 2. So we're going to go ahead and put those in as our side lengths on our triangle. It's a bad triangle that they drew here. Clearly one side is shortest, so let's pretend that's the shortest. This actually looks like an isosceles triangle. Oops, I'm labeling it wrong. I can't talk and write. So this one would be x. Let's say this one's x plus 1, and we'll say this one is x plus 2. It doesn't matter how you label your triangle, you guys. Sorry. I tried erasing a crumb off of my Surface Pro, thinking it was a mark on the screen. Okay. All right. So once you've labeled it, you just kind of have to sit there and think, is there anything that I know of about right triangles, right? And there's a lot of things we know about right triangles. We know that we could use maybe some trig like sine, cosine, tangent, whatever. We could use the area formula, 1/2 base times height, right? But in this situation, since we were given only side lengths and we weren't given any angles, that makes me lean towards a squared plus b squared equals c squared. That's the Pythagorean theorem, okay? So since, caps lock is on, since we are only given side lengths and not angles, we will use the Pythagorean theorem. A squared plus b squared equals c squared. It's a bit bigger. Oops. A little smaller. Okay. All right, so let's go ahead and write our formula down. A squared plus b squared equals c squared. Remember, you can only use this on right triangles, okay? which makes sense because C is always the hypotenuse. Doesn't matter who A and B are. So you can put in there whatever you want. So I'm just going to go let X be A. I'm going to let X plus 1 be B. And then C always has to be the hypotenuse. That's the one that does matter. So make sure you got C right, okay? All right, so we got X squared plus, and we've got to make sure that we FOIL out X plus 1, right? So we got to do X plus 1 times another X plus 1. So we're going to get X squared, 1X, 1X, 1. So this is going to be X squared plus 2X plus 1 when we combine these two middle terms, okay? All right, so I'm going to go ahead and put that in here. X squared plus 2X plus 1. Then we're going to have to do the same thing for the X plus 2 squared, right? We're going to have to FOIL it out or distribute it out. We got X times X, which is X squared. 2X, 2X, 4. And these middle two terms, this 2X and this 2X, they're going to add up to 4X. So that's what we'll insert on the right-hand side. I'm starting to feel like we might have done it right, you know, because I'm getting that quadratic equation. I'm getting an X to the second. So this looks pretty good. All right, so if we combine this X squared plus X squared, that's going to be 2X squared. Okay, here we go. So since we have an X squared, we want to get everybody on one side. So I'm going to move all of these that way. I do not want to do it the other way. I do not want to move all of these that way. To make sure everybody understands why. If I decide to subtract the X squareds, right here, I'll get a negative. 1X squared minus 2X squared, I'm creating a negative for myself. And we never want that leading coefficient to be negative, okay? So we're actually going to subtract all of these over to the other side. That's the way we're going to move it. All right, so let's see what we got left. 2X squared minus 1X squared, X squared. 2 take away 4, 1 take away 4. And over here is absolutely nothing. Now I'm definitely factoring this one. I would not use the quadratic formula. It would take way too long because the factors of -3 that add up to -2. Well, the only factors of -3, you guys, are -3 times +1 or -1 times +3. Let's see, we need it to add up to -2. So this must be the winner. It's going to add up to -2, right? So in our parentheses, we're going to put X minus 3, X plus 1. And we know that we set each piece equal to 0, right? You can see here when we move the 3 over, it's going to become positive. When we move the 1 over, it's going to become negative. Now, just because it's negative doesn't mean it's automatically out. You do have to go back and make sure, you know, sometimes a negative does work, right? So let's go and check. If I were to put a -1 in there, I would have a negative length. I'd say that, oh, the side of that triangle is only -1 long, right? Not allowed. Okay, so again, no negative lengths, distances. No. So it looks like X equals 3. So we go back up here to the top and we plug in X equals 3. So the first one's 3, the next one's 3 plus 1, so it's 4. And the next one's 3 plus 2, so it's 5. So it looks like the side lengths of our triangle are going to be 3, 4, and 5. I don't know what we're measuring with. It doesn't say like yards, meters, feet, whatever. So I'm just going to leave it without any units, okay? All right. Let's try another one. Just can't do enough word problems, right? They're tough, so more practice, the better, right? And they show that you're not just getting answers and doing the class to get a grade, but that you can apply the math to your life. Okay. All right. So let's see here. The width of a rectangular box. So we have a box. So we got, I guess I could just use this. It's not going to be perfect, you guys, but that's fine. Oh, that's not what I meant to do. Select it. Okay, so this, I guess, would be our rectangular box, right? So the width of a rectangular box is 7 inches. So I'm just going to put 7 inches here. I'll just label them W. Make a better W. There we go. The height is half of the length X. Well, that tells me a lot. That tells me that the length is X and that the height is half of X. So we have this completely labeled. These are all inches, by the way. Okay. Now the volume is 4,046. Well, little known fact, you could Google it, right? But hopefully you remember it. Volume equals length times width times height. So once I write it up there, I'm sure you're going, okay, yeah, I've seen that. All right, so let's go ahead and substitute in. So the volume is 4,046. So we're going to put that in for the V. The length is X. The width is 7. And the height is 1/2 X. All right. So now we just have to multiply all these, right? So here we go. Trying to think about the best way to explain it. So let's go ahead and do the first two, which would get us 7x. And then we would take that and we would multiply it by the 1/2, right? So the 7 would have to go over 1. So 4,046 equals, remember, you just multiply straight across. So the 7 will multiply by the 1. The 1 will multiply by the 2. Don't forget x times x is x squared. All right. So I'm going to go ahead and get rid of the fractions like we did on the last problem or the problem before by multiplying by 2's. I'm going to make the fraction cancel here. So 2 times 4,046 would be 8,092, I believe. And then 8,092 divided by 7. It's going to pull out my calculator. Okay, again, so why am I doing that? If I want to get the x by itself, since the 7 is multiplying, I have to divide, right? So my calculator says this. It's always nice when it's a whole number, huh? And then to get rid of the squared, we square root, which we learned last section. And we said last section, don't forget what anytime you square root both sides of an equation. Hopefully you're saying you're plus or minus. All right, now I'm going to try and square root 1,156. So let me see if it works. It's 34. Cool. All right. So it's 34, but remember that plus or minus in this case doesn't make sense because you can't have negative 34 as the length of your box, right? So we got positive 34 and we got negative 34. And again, like the last few, can't be negative 34. No, negative heights. All right, so x equals 34. Here's one of our answers, right? Okay. So now we just need to take that 34 and plug it into the heights, right? So if the height is 1/2 of x, then the height is 1/2 of 34. We talked about this last time. Half of 34, you just literally need to divide it by 2, figure out half of it. So 17 is what I'm getting. So let's put it all together in a nice little answer box here, okay? We know that the length is 34, and we actually know what we're measuring with, you guys. We're measuring with inches. Okay, you can see right here, we're measuring with inches. So 34 inches. We know that the width is 7 inches, and we know that the height now is 17 inches. All right. Okay, so that was number 3. Number 4, I think we only have, yeah, 7. It's there. Okay. Write an equation representing the fact that the sum of the squares of 2 consecutive integers is 113. So I'm looking through it and I'm seeing that I have the sum, which means I need a plus sign. And we have the sum of squares. So I have to take something and square it, and take something else and square it, and I have to sum them, so I have to add them. So this is what it would look like to say the sum of 2 squares. Okay. Now what is it that we're squaring? 2 consecutive integers. So 2 consecutive integers. We just said a second ago that if you have 2 consecutive integers, you call the first one x no matter what. And the next one would be 1 away from it. So it'd be x plus 1. Okay. So the first integer is what we're calling x. The second integer would be what we're calling x plus 1. All right, and it is 113. So we're just going to set it equal to, right, 113. So there's our equation. It feels good to be able to write down the equation. All right, so we got x squared plus, and then off to the side, I'm going to go ahead and do x plus 1 times x plus 1. I think we just did it a second ago. So if you want to just peek back and steal it, you can. All right, I'm just going to refoil because I don't know where we're all at. See that. All right, so it's going to be x squared plus 2x plus 1. All right, and then we're going to combine x squared plus x squared. So 2x squared. We got to get everybody on one side. So let's subtract the 113 over to the other side. One, take away 113, just be negative 112. Now this is kind of a special equation. You can see that everything's even, which means everything is divisible by 2. So if we divide everything by 2, we're going to give ourselves an easier equation to solve. And I can instantly think of the factors, right? We're looking for the factors. If you know your times tables really well, you're probably on it. We're looking for the factors of negative 56 that add up to the middle number, positive 1. I know it's got to be some kind of 7 and 8, right? Since it's a positive 1, we'll put the negative on the 7. That way, when you add these two together, you get a positive number. Okay. All right, so in the parentheses then, it's going to be x minus 7 and x plus 8. So when you set them equal to 0, you get 7 and you get negative 8. Okay. So negative 8 can work. We don't have any lengths here, you guys. These are just abstract numbers. There's no, I didn't measure a table, or there's no box, there's no triangle, right? So we can actually keep both. So that means we're going to have 2 solutions, right? We're going to have the solution where oops, the first integer is x, right? Which is 7. So then the second integer, which is x plus 1, would be 7 plus 1. So it would be 8. So that would be 7 and 8. But we're going to have another solution, right? Where the first integer would be negative 8. Oops, sorry, which is x, right? So then the second integer is going to be x plus 1. So it's going to be negative 8 plus 1. So it's going to be negative 7. So negative 8 and negative 7. Now what I want you to notice is why we're getting two solutions here. Remember we said the sum of the squares of these is 113. If I were to take the sums of the squares, so 7 squared plus 8 squared, that'd be 49 plus 64, which, yep, that's 113. If I did the same check over here, I'd have to square negative 8 and negative 7. But a negative times a negative is a positive. So I'd get the same numbers. I'd get 64 and 49. Those are the exact same numbers, you guys, right? So it makes sense, actually, that we're getting two solutions off of this. Okay. All right. Number 5. The length of the longer leg of a right triangle. So it looks like we have a right triangle, you guys. So let me go ahead and draw that. It's not isosceles. It says there is a longer leg. So let's just draw it like that. The length of the longer leg is 8 feet longer than the length of the shorter leg x. Read this, the shorter leg is x. So I'm going to label the shorter leg x. Okay. And in green, I'm going to get all of this. The length is 8 feet longer than the length. So it's going to be x, since it's longer, plus 8. The hypotenuse is 8 feet shorter than twice the length of the shorter leg. So 8 feet shorter. So whatever, it's going to be a takeaway 8. If longer was an add 8, then shorter is going to be a takeaway 8, right? And what am I taking it away from? Twice the length of the shorter leg. Well, here's my two legs, you guys. Okay. The shorter leg is going to be this one right here. So it's going to be x long. So twice the shorter leg would be 2x. Okay, so that shows you the hypotenuse being 8 feet shorter than twice the shortest leg. It's a lot to digest, huh? Okay, so we've labeled it and it says find the length of all three sides. I think we know from example 3 or example 2, right, that we should be using the Pythagorean theorem again, since we have all side lengths, right? Again, we will use the Pythagorean theorem since we have all. Okay, so let's go ahead and set up that good old a squared plus b squared equals c squared. Now, because we're starting to get good at this, you guys, I might speed it up the tiniest bit, not a bunch. So remember, it doesn't matter what you let a and b be. So I'm just going to let x be the a, and I'm going to let x plus 8 be the b. It does matter who c is. C has to always be the longest side, the one opposite the right angle, the hypotenuse. Okay. All right, so if I take x plus 8 times x plus 8, here is what I get. If I take 2x minus 8 times 2x minus 8, this one's kind of complicated, so maybe I'll do it off to the side just to make sure you're all with me. Let's see here, we're going to get 4x squared minus 16, minus 16, plus 64. So when you combine these negative 16, negative 16, you're going to get negative 32. Bam. So that one was definitely a little bit tougher. You're going to find yourself, if you're not already, doing these in your head because you'll have foiled so much in this class. All right. I'm going to combine like terms. So let's go ahead and add these together. All right, let's get everything on one side. And we're going to move all of these that way. That way we keep our leading term positive. Because right now, if I take away 2x squared from the 4x squared, this quantity will still be positive. Okay, so I'm going to actually subtract all of this stuff over to the other side. We might as well do it in one shot, you guys. That way, gone, gone, gone. So there's nothing left here. And gone. So this is different. We don't have to factor in the traditional way where we use that X method or the AC method or anything. Remember we said that if there's an X squared and an X, you just factor out the GCF, okay? If there is an X squared and an X, factor out the greatest common factor. All right. So if we do that, the greatest common factor here would be 2x. If we divide by 2x, we got x. We divide by 2, it'd be 24. And we took out the x. So now we're just going to set each piece equal to 0. We're going to set this piece equal to 0. And this piece equal to 0. So if we divide by 2 here, we're going to get that x equals 0. And if you move the 24 over, whatever, add the 24, and you're going to get x equals 24. All right, now, one of these is bogus. I mean, if you look at this x equals 0, right? There is no way that x could be 0, because then we wouldn't even have a triangle. It's like, yeah, it's 0 tall, you know? So this one's out. So it looks like x equals 24. So if x equals 24, then the x plus 8, right? The x plus 8 will be 24 plus 8, so 32. And the 2x minus 8, the hypotenuse, let's see here, that's going to be 48, take away 8, so it's going to be 40. And all these are measured in, I'm missing the word problem, feet, you guys. So all of these would get feet, feet, and feet for our answer. I hope you're starting to kind of get a rhythm. I mean, this has a lot of pieces of other things that we've had. It's still hard, don't get me wrong, but hopefully it's starting to sit a little better. All right, this one's pretty easy, at least in terms of what the setup. You don't have to struggle too hard with that part. It's one of those, do you know what the variables stand for? So you can see here, E stands for dollars, and you can see that X represents the number of years since 2004. So when they say to us, determine the average weekly earnings in 2007, the first thing we have to figure out is how many years since 2004. Okay. So how many years since 2004 is 2007? So the math that we would need to do for that, right, We would just need to subtract. So if we do 2007, take away 2004, it's been 3 years. Or some of you are like, Mecklenburg, why are we even writing that down? All right, so 3 would go in for the E or for the X. That's what you got to think about, right? Well, E stands for dollars, so that doesn't make sense. X stands for the number of years since 2004. So we're going to put this in for the X, right? So here is our equation. It's going to be E equals, 0.12 x squared, so 3 squared. All right, so I'm going to pull out my good old calculator and just have it do its thing, right? You can put it all in just because I don't know what kind of calculators people are dealing with. Maybe I'll do each piece, okay? But normally I would put it all in. We have a good calculator. All right. All right, so I've got 57948 as the E. Okay. And remember what it stands for. That's how you'll be able to catch some mistakes, right? E stands for the average weekly earnings in dollars. So, could somebody make $579 in a week, back in 2007? Sure, right? That would put them around what? 3,000, maybe between 2,000, 3,000 for the month. Okay. All right, so that sounds reasonable. I'm going to put a dollar sign on it just to give it some meaning. Okay. Now, the part B, it's a little tougher because, well, let's see where we're putting the 638. In what year did the average weekly earnings reach $638? So this has to be the E now, not the X. It's not the number of years since 2004, right? It's dollars, and we know E's in dollars, right? So we're going to put the 638 in where the E is in the original problem. So I'm going to put it right there. So this one's a little bit tougher because it's not I just need to plug this thing into my calculator. It's a quadratic equation that we're going to have to solve, okay? So we know with quadratic equations, we always have to get it set equal to 0. So move the 638 over. So that way we do have a 0 over here. And then 555, take away 638 on the calculator, negative 83. So I'm going to use my calculator for a lot of stuff here, you guys, because clearly this was designed to be a calculator problem. Okay. So I'm going to use the quadratic formula because we haven't done it today. And this one seems the easiest probably if we did use the quadratic. So let's remind ourselves x equals negative b plus or minus the square root of b squared take away 4ac all over 2a. All right, so at this point, you've done your homework on this section. So you're probably pretty good at it. So we can see that a is going to be the 0.12. B is going to be the 7.8. And C is going to be the negative 83. So let's go ahead and substitute it in. So negative b plus or minus b squared take away 4a c all over 2a. Let me see how far down the screen I'm getting, how small this is going to end up being. Ooh, it's getting kind of small. So I'm going to move up over here. All right. So 7, I'm using my calculator for a lot of this, you guys. So some stuff might seem magical, but I'm assuming you have your calculator next to you too, okay? So I'm gonna get the stuff underneath the square root. I'm just gonna punch that all into my calculator in one shot, okay? 7.8 squared. Okay, I got this. Okay. So let me just double check it again. So on my iPhone, and I couldn't find a real calculator. Yeah, that sounds about right. Okay. All right, divided by 0.24. Okay. Alrighty, so I'm going to do two cases, you guys. I'm going to do the case where it's negative 7.8 plus. And then I'm going to do the case where it's negative 7.8 minus. Now, I can kind of reason out that one of these is going to be bogus. I can tell that this top one is going to be negative because a negative take away more is still negative, and a negative divided by a positive is still negative. And we can't have negative years since 2004. Okay, we're not going to go back in time. So this one's actually going to end up being bogus. And if I can spot that, then I won't do it. But I don't know if some people could spot that. So we are going to do it out. Okay. So this first one's going to be the one that matters. It's going to be the one that we're going to keep, in other words. All right. So let me see here. So I'm punching this into my calculator, you guys. I'm getting 9.3 for this one. Okay. 9.3. All right, now I'm going to go to the other one. Negative 74.3. Okay, so we're going to cross off the negative 74.3, and that's because we can't go back in time. Okay, this model's only good for after 2004. It's a little lower. No negative time. That goes for when you're in my calculus class too. All of our time is going to be positive. So no negative time. Okay, allowed. All right. So 9.3, let's see what we're supposed to answer. In what year? Okay, so if it's been 9.3 years since 2004, right? If you go back up here to the directions. Okay, so 2004 plus 9 would be 2013. So we're somewhere in 2013, you guys. Let me make sure I write that out. 9.3 years since 2004 is 2013. The 0.3 part means that we're just midway, right? We're a third of the year in. So, you know, we might be in the fourth month, right? We might be in April of 2013, but we're still going to be in 2013. Okay. So 9 years since 2004 is 2013. So that's going to be the answer, you guys. So don't even worry about the decimal. All right. Let's go ahead and go to our last problem. So right here we have a model for projectile motion on the planet Earth. It's only good for Earth because well, no, this is good for anywhere, but the one that I'm going to write down in a second is only good for Earth. So you can see right here, these gravity constants, these are the ones for Earth. If we're using feet, it's going to be 32. If we're using meters, then it's going to be 9.8. They've been rounded a little bit, but that's okay. Okay. So the moon will have a different one, right? Another planet will have a different one. So if you take your S and you replace the G, the gravity constant, with 32, leave everything else the same. Half of 32 is 16. So this is a well-known formula. And if you take my calculus class, you'll have this guy memorized. This is just the formula for projectile motion on Earth when we're measuring in feet. Okay. If we did that same thing, but we substitute in, instead of 32, we substitute in 9.8 because we're going to be measuring in meters. Okay. Then you end up with 4.9, which if any of you have ever taken a physics class, you probably recognize the negative 16 and the negative 4.9. So the reason why they're negative is because as soon as a projectile is shot from the surface of the Earth, right? Oops, I don't know what I'm talking about here. Meters. Okay. As soon as a projectile shot, what's gravity going to be doing to it? Well, gravity is going to be pulling down on it, right? And so that's why that front number always has a negative on it, right? Negative 16 and negative 4.9. Okay. And this projectile motion, it isn't projectile motion like this, like this. That would be more complicated. That would require some trig, different kind of calculus. Okay. The only projectile motion that we're going to allow in this class, and even in Calc 1, is this kind of projectile motion straight up and down. You can see that here. So it just has to be some up and down movement. It doesn't have to be the up and the down. Maybe we'll have a problem where we're on a building and there's a guy up here and he's just going to drop something down. Okay. So, but as long as it's straight up, straight down, straight up and down, whatever. Okay. We're not going to have any movement that's going to go sideways or be parabolic, right? Have a parabola shape. Okay. Now, when I graph this, the graphs of this, they do look parabolic because the way we graph them is we put time along the x-axis and we put height, or s, along the y-axis. And so while the object is moving like this, let's say it hits 16 and then it comes back down, what I'll graph is I'll graph this parabola, because I'll show you at 1 second, you know, it was this high. At 2 seconds, it was this high. Let's say at 3 seconds, it reached the maximum of 16. Well, then it's going to hit this same height over here a second time on its way down at 4 seconds, right? It's going to hit this same height at 5 seconds, etc. Okay. So it's like I took this curve right here and kind of pulled it and stretched it out this way, if to make it in terms of time. Okay. But this is not the path that the particle is taking, right? The particle is taking up and down. But when we graph it, it looks like a parabola because we stretched it out in terms of time. So hopefully that makes sense why we have a parabola here, right? This is a t squared. Some of you might remember from a high school class that anytime it's x squared, it's always a parabola. So the graphs of these will always be parabolas. Okay. An arrow is shot from a height of 6 feet straight upward with an initial speed of 10 feet per second. So because we're measuring in feet, we want to make sure that we use the first formula with the negative 16. Since we are measuring in feet, should the first formula with negative 16. So you got to read through, decide, okay, which one of those am I going to be using? So I'm going to use this one, s equals negative 16 t squared plus b naught t plus s naught. Now, let's talk about what each one of these variables stands for. S is going to stand for in this class, it's best to think of it as the height, position, height, whatever. So I'll put position or height is the best way for you to think about it. Time t. S naught then must be the same thing. It must be the position or height, right? But it's going to be the height when t is 0. In other words, we call that the initial height. So the subscript of 0 on that, the S naught, the S sub 0, this 0 indicates the time. So if I write S sub 2 and I say on a test, find S sub 2, I'm saying find the height when time is 2, or find the position when time is 2, okay? All right, so then you might gather that V naught, well, V stands for the velocity. So V naught is going to be the velocity when time is 0. In other words, the initial velocity. All right, so you can see here, it says it has an initial speed of 20 feet per second. So that's going to go in for the V naught in this problem, okay? And the arrow is shot straight up from a height of 6 feet. So that's going to be our S naught. So you read through and you figure out what's going to be your V naught and what's going to be your, in other words, your initial velocity and your initial height. Okay. And we'll just substitute those into the formula. Okay, so this is going to be a model that's going to give us basically the arrow's height at any given time, right? Now notice you plug a 0 in for all these t's, these will all go away and you'll just have 6. And that should make complete sense. When time is 0, where's the arrow? Well, it's 6 feet high because it said that we shot it from a height of 6 feet, right? You plug a 1 in, you should be a little higher. You plug a 2 in, probably a little higher, etc. Okay, so this is going to give us the height at any given time in feet. Now, I do want you guys to know that the initial velocity can be negative. We shot this upward. It could have easily said something like you threw something downward. You know, if you throw something downward, then the initial velocity wouldn't be positive, it would be negative. Because if you think about it, velocity is kind of how fast something's going. And so if I throw it upward with the speed of 20 and I throw it downward with the speed of 20, that should change the problem, right? And so make sure upwards get a positive and downwards get a negative for this particular problem, this projectile motion. All right, so part B says, well, how long will it take the arrow to land? Well, we have a model. This is the model we just wrote on the last slide. And the thing that you have to think about is how long means we're trying to find the time, okay? We want to know when the arrow lands. Well, remember, S stands for its position or height. If an arrow has landed, then it's on the ground. So that means its position or height must be 0. S stands for the position or the height. So if the arrow has landed, it must be on the ground with a height 0. Now, these are really silly problems. I mean, who shoots an arrow straight upwards, right? Like, these are silly, but they have to be silly like that because we know that the only type of projectile motion we're allowed is straight up and down, okay? But really, who's going to shoot an arrow upwards? So this is kind of contrived, but we're just trying to rehearse our skills here, okay? All right, so we got S equals. I'm sorry, we don't have S equals, okay? We have 0 equals, right? We just found out S equals 0. And notice we're going to solve for the t. And that should make complete sense that we're going to solve for the t because it says how long. In other words, what's the time? All right, so I'm going to divide everything here by a -2. I noticed that 2 goes into all of them. And the reason why I'm choosing to divide by a -2 is because it's going to make my front term positive. A negative divided by a negative equals a positive. And I really want that front term to be positive. All right. So for this one, we can do the quadratic formula. It turns out it is factorable, I think. Let's see, factors in -24 that add up to -10. So -24 would be what, 12 and 2? Right, 12 and 2. It looks like the negative would have to be on the 12. So we could factor this by the AC method, right? Okay, so I did the AC method. I did the first times the last, the A times the C, and that's where the -24 came from. Okay, and we found the factors in blue to be -12 and 2. So I think this is only the second time we've done this in class, so this should be kind of like, huh? And that's totally fine. So we're going to use the -12 and the +2 to just rewrite this -10t part, you guys. Notice the rest stayed the same, right? 8t squared, -3. So we're just re-expressing the middle. And this is when we use factoring by grouping, where you slice it down the middle and you say, okay, what can I take out of the first two? Definitely a 4 and a t, right? You have to take something out. Even though these already match, you guys, we still have to take something out. In that case, take out a +1, a +1. Remember, you always have to take out a sign too. So oops, so this sign, you just bring it down. So we took out a +1. What does taking out a +1 do? Absolutely nothing, because dividing by 1 does nothing. The one that shows up twice is going to be one of your parentheses. And the leftovers, since you factored it out, will be the other. So we're going to set each piece equal to 0. Or 2 plus 1 equals 0. Move over the 1. Divide by 4. So we're getting this bogus solution. We said no negative time in this class, no negative time in our calculus class either. Okay, we're not allowed to go back in time. But if you think about the graph, right, we said it's a parabola. Here's the picture. We're starting at 6 feet. And our parabola, our story goes like this. We shot it, it's going to reach its maximum height, and it's going to come and hit the ground. Now, really, how did it go, though? Remember, it went like this, right? That's the movement. But we stretch it out over time, right? Okay, so this would be when time is 0. And clearly, it hit the ground when t equals 3/2, which, by the way, put it in your calculator, that's 1.5 seconds. Okay. It's giving us -1/4. It's giving us -0.25 because it's thinking about the whole parabola, right? So it's giving us this extra solution because it's thinking about this entire parabola, you guys. It doesn't know what our story is, right? It doesn't know that that part isn't really part of our story. So we have to cross that off and just take t equals 3/2. So how long will it take the arrow to land? We'll say it will take the arrow 1.5 seconds to land. All right. Box that so we know where our answer is. And that is it, you guys. So I basically did, your homework's not very long. It's usually I give like maybe 20, 30 questions. You know, this one's single digits, I think, maybe. Might have crept into 11 or 12 if I gave a couple of simpler ones, but these notes, have them out. They're going to help a bunch because I tried to mimic these questions So that way, you had a little exposure to them and it'd be a little bit simpler. Okay. All right. If you take a long time doing it, that's normal. These are word problems, right? It should take a while doing each one, way longer than all the other problems on the past assignments. And that's okay. I made the assignment much shorter. Okay, so it's okay to take a long time. All right, guys, best of luck. Take care, everybody.